disadvantage of this impulse invariance, and then we will go for the bilinear transformation technique. Okay, so write down one question, one more numerical based on this. Convert an analog filter convert an analog filter with system function h of s. Convert an analog filter with system function h of s into digital filter into digital filter using digital IR filter, digital impulse invariance, using impulse invariance method, using impulse invariance method. Once again I am repeating, convert an analog filter with system function h of s into digital IR filter using impulse invariance method, using impulse invariance method, using impulse invariance method. Write down h of s. h of s is equals to h of s is equals to 10 upon h of s is equals to 10 upon s square, 10 upon s square plus 7s plus 10. h of s is equals to 10 upon s square plus 7s, s square plus 7s plus 10. Okay, so in this question h of s will be given, this kind of question, in this kind of question h of s will be given. Okay, that h of s, this function, and you need to just transform that h of s into h of z. Okay, and as I told you in last lecture, so you need to use partial fraction. Either you can use partial fraction or you can use that numerator to denominator dividing method, or you can use residue method, no issue. Okay, so just you need to make the part of that h of s. Okay, so s square. Now here also in partial fraction also you will get some different method. Okay, like that a1 a2 you need to find out, or sometime this denominator, the denominator it is given in a some different way. Okay, so you can use that a plus bs plus c, that method. Okay, so depending upon this denominator you need to observe the denominator. Okay, so this is your function. Yeah, please. A square plus 7s plus 10. Okay, so this is your h of s. Now you need to make a part of this. So h of s is equals to, you can observe the denominator. Okay, so here it is quite simple. So 10 upon the denominator, so 7s and 10. Okay, so 5 into 2, so multiplication will be 10, and 5 plus 2, so this will be 7. Okay, so you can make a part of this, that is s plus 2, and in another bracket es plus 5. So you, if you take the multiplication of these two bracket, you will get the same thing. Okay, so here, so here, you can write this as a a1 plus 2 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 you can take other variable also, c1 or something else. Okay, so s plus 2, then plus a2. Now you need to find out this a1 and a2 by using partial fraction. So s plus 5. Now partial fraction is possible for this. Okay, so to find out the a1, so this will be for a1, h of s will be your as it is. So that is a 10 upon s plus 2. You can write it simultaneously. If any calculation mistake is there, so you can point out that. Okay, so you need to solve this simultaneously with me.
So what is sampling frequency?
Sorry, what is
Sampling frequency for this question.
sampling frequency?
Yes, sir.
So that is in Chebyshev filter, na? Or what?
So after partial fraction, we need to write the to
Just,
get this
just, just,
P
just
of
hold
S,
on.
right? Sampling period.
Sampling theorem. Yeah. Do you asking? Is there any question in this numerical? It is not related to numerical, na? Right now.
No, sir. It's related to numerical. Like what I'm asking is, what is the frequency? So we need to find T of S, right?
Yeah.
So frequency is missing.
Okay. So for this frequency is missing, like that question. Your
Yes, sir.
question
Yeah.
is. Yeah, yeah, yeah. So yeah, it is not given in a question because that TS to find out the sampling time, TS, है ना?
Yes, sir.
You require that frequency, so you need to invert that frequency. That is 1 by fs, whatever frequency is given. So you need to invert that. Okay. So it is not given. So you what you can do? You can keep that TS as it is in your numerical.
Okay, sir.
Okay. And if it is given, so you can use that. But if it is not given, so what you can do? You can keep that TS as it is. No issue. That indicates sampling time.
Okay, sir. Thank you.
Getting? So okay, so this here you need to find out the a1, and for a1, so that is a pole 1, this one. Okay, so you need to write that bracket, that is s plus 2 with this, and that is s is equals to minus 2. So at this pole you can solve this. Okay, so this s plus 2, this will be cancel, and this s is a minus 2, so this will be minus 2 plus 3, so this will be simply 10 by 3. So 10 by 3, that means this a1 will be, and so this a1 will be simply 10 by 3. So that you can write, this is simply 10 by 3. And in the same manner you can calculate a2 also. So if you are calculating a2, again same thing will be there, and you need to replace that s plus 2, s plus 5 into, so this will be s plus 5, that 5 s is replaced by minus 5. Okay, so it is correct.
Yes,
So
yes.
this will be cancelled out, and here s is minus 5. So minus 5 plus 2. So this will be what? Minus 3. So 10 to the power minus, sorry, 10 divided by minus 3. So this is plus 3 and this is 10 divided by minus 3. Correct? Okay. So this will be your h of s. So from this you can write the h of s. Okay, from the value of 1 a1 and 2. Okay. So this will be 10 by 3, 10 by 3, and this s plus 2, and the next one is a negative, so this will be negative 10 by 3 and s plus 5. Okay, now you can write that. Okay, you can keep ts as it is, no issue, or you can take ts is equals to 1 also. That is also means you can consider it is not given, so you can take ts is equals to 1 second. Okay, if you want, otherwise you can keep as it is, no issue. Okay, so here to transfer this function, that is 1 upon this function, to transfer that 1 upon s minus pk. So if you remember this formula, s minus pk is nothing but the pole over here. Okay, so that is nothing but the 1 upon, so e raised to power, sorry, 1 minus e raised to power. So this is what, 1 minus e raised to power minus pk, minus pk into ts, pk ts. Okay, so you can keep that tk, sorry, ps as it is into z inverse, into z inverse. Okay, so here for the first one, that is a 10 by 3. So s plus 2. So here pole is s is equals to minus 2. So pole is minus 2. Okay, so you can write this as a 1 upon, as your pole is minus 2. So this will be 1 upon 1 minus e raised to power minus 2, and ts you can write as it is, and z inverse. So z inverse you can take over here also. So this will be z, and 10 by 3 is as it is, so 10 by 3 z. Okay, instead of writing here z inverse, you can write this as a e to the power minus 2s upon z, and that upon z will go here, and then denominator z will go into the numerator. So you will get finally this value, 10 by 3 z upon z into e to the power minus 2s z. So this is the first one, first function. Okay, in the same manner you can write the your second function, that is a t2, sorry, that will be again minus sign is there. Okay, so from that you will able to write the next function. I am directly taking z, h of z. So your h of z will be your first function, or from this you can take 10 to the power outside, 10 to the power 3 outside. You can take this because it is the same thing, same. Okay, so you can take 10 to the power outside, and this will be z upon z minus e to the power minus 2 ts. Okay, then negative, it will be z upon, again this will be z upon, now your pole is minus 5. Okay, so this will be z minus e to the power, sorry, z minus e to the power minus 5 ts. Is there any doubt in this? So this will be your final answer, that is h of z is equals to this one. This one will be your final answer. Is there any doubt in this?
No, sir.
Yeah. So this is a simple numerical. Okay. Now we will take one more numerical based on this. Take this numerical as a homework, then we will take another type of numerical. Okay. Transfer analog filter transfer function, transfer analog filter transfer function h of s given below into a digital filter transfer function h of z into a digital filter transfer function h of z using impulse invariance transformation method, using impulse invariance transformation method with t, capital T is equals to 1 second, with capital T is equals to 1 second. Okay, if it is not given, by default also you can take a t is equals to 1 second, no issue, or you can keep that ts as it is. Okay.
Can you repeat the question?
Yeah, I will repeat. Okay, transfer analog filter transfer function h of s given below into a digital filter transfer function h of z, transfer analog filter transfer function, that is h of s given below into a digital filter ट्रांसफर फंक्शन एच ऑफ जेड, एच ऑफ एस को एच ऑफ जेड में ट्रांसफर करना है यूजिंग इम्पल्स इनवेरियंस ट्रांसफॉर्मेशन मेथड, यूजिंग इम्पल्स इनवेरियंस ट्रांसफॉर्मेशन मेथड with t is equals to 1 second and your h of s is equals to, write down, h of s is equals to 0.5 in bracket s plus 4 in denominator write down, in one bracket s plus 1 and in another bracket s plus 2, in numerator 0.5 in bracket s plus 4. Okay, so again same partial fraction you need to use, 0.5 s plus 4 upon s plus 1 s plus 2. Okay, here your h of s is something different, nothing else. Okay, h of s जो है वहाँ पे डिनोमिनेटर में कोई सॉरी न्यूमरेटर में कोई कांस्टेंट वैल्यू होने के बजाय वहाँ पे क्या है, पॉलिनोमियल है. h of s is equals to, it is a 0.5 in bracket s plus 4, this is what, s plus 4. Okay, and another one in bracket s plus 1 and in next bracket that is s plus 2. Okay, so here what you need to do to find out the a1, how you can find out the a1. So first one, to find out the a1 you need to write this as it is and s plus 1 into multiplication, and that is at s is equals to minus 1. Okay, so this s plus 1, this will be cancelled and this s is having minus 1 value, so here also you need to put that, so that will be 0.5 into s is what, minus 1, so this will be minus 1 and plus 4, so this will be 3. Okay, into 3 and then s plus 2, so this one, so minus 1 is there, so this will be 1, so this will be simply 0.5 into 3. Okay, so 0.5 into 3, so this will be 1.5. Okay, so this is a simply 1.5. Okay, a1 will be simply 1.5. Okay, So in same manner you can calculate a2 also. Okay, so for a2 what happened, that s plus 2, so that term will be cancelled and this will be simply 0.5 and value of s will be minus 2, so this will be 0.5 minus 2 plus 4, so that will be uh, into 2, so this will be into 2 upon this s plus 1 will be there, s plus 2 cancel ho jayega, so s plus 1 is there and value of s is minus 2, so this will be minus 2 plus 1, so this will be simply minus 1. Okay, so this will be simply minus 1. Okay, so like this you will get the value of a1 and a2, just put the values and try to find out the h of z. Okay, so we will take another question. Write down next question. Determine h of z. Determine h of z. Is there any doubt in this question? ये सॉल्व कर लोगे आप लोग?
नो सर, हाँ कर लेंगे.
Yes.
Yeah. So determine h of z using impulse invariance method. Impulse invariance method for the system function. For the system function h of s is equals to h of s is equals to 1 upon 1 upon five s plus 0.5, sorry, s plus 0.5 in s square plus 0.5 s plus 2. It is quite difficult for the partial fraction. Okay, so h of is something like this. Okay, so here number of poles are not exactly visible. Okay, so you need to simplify this. Okay, so you need to write this function h of s is equals to means, so h of s is equals to, you need to write this function, that is a upon, that is your first bracket, that is s plus 0.5 s plus 0.5, and next part you need to write this as a plus bs plus c, bs plus c. Okay, so here bs, because this is a polynomial of the having the power 2. Okay, so this will be simply s square plus 0.5 s plus 2, and you need to solve this. Okay, how you can solve this? Just take the cross multiplication of this. Okay, and that is equals to your h of s, and h of s is this one. Okay, 1 upon this one. Okay, so if do the cross multiplication, so what happen in numerator, you will multiplication, take the multiplication of this a into this one and bs plus c into this one, this term. Okay, and in denominator you will take the multiplication of both the denominator, this one. Okay, and that is equals to h of s, so h of s is having same denominator. Okay, and that denominator will be cancelled, so here this will be 1 is equals to numerator h of s ka jo numerator hai, that is 1 is equals to this denominator is going to be cancelled 1, so I am not writing that, just you need to write the multiplication. Okay, and we are multiplying a to this one. Okay, so I will take the multiplication simultaneously. So this will be a s square, then plus a 0.5 s. So you can write this as a 0.5 yes. Okay, then plus 2a. कुछ डाउट है इसमें, कुछ डाउट है?
No, sir.
Yeah. Then the next one, I'm taking cross multiplication of this. Denominator I'm cancelling with the h of s. Okay. So this will be 1 and this multiplication. So with s I will multiply first of all to this one. Okay. So this will be b s square, b s square, b then plus cs. Okay. cs. Then with 0.5 I will multiply to this. Okay. So this will be plus 0.5 b yes. Okay, then 0.5 plus c, sorry, into c, 0.5 c, and that is equals to 1. Okay, so now this equation you can write, this one you can write like this: 0 s square, this is what, 0 s square plus 0 s plus 1. Okay, this is a one, just for the simplification I am writing like this. Okay, because I want to separate this term. A s square के जो भी terms है, that you need to combine and compare with this 0 s square. Okay, so here ये a s square plus b s square. Okay, और कहीं s square है, नहीं है. Okay, so from this you can write the equation by combining this s square term and comparing with the this left hand side, you can say. So you can write a plus b, a है और b है. Okay, so I'm taking that s square outside. Okay, so this will be a plus b s square is equals to 0. Okay, and that 0 s square I'm taking to this side, so that will be 0. Okay, so this you will get the first equation from this, that is a plus b is equals to 0. कुछ डाउट है इसमें? ओके, यू कैन मार्क दिस एज इक्वेशन नंबर 1. क्या किया मैंने, एस स्क्वायर के सारे टर्म कंबाइन किए. ओके, उसमें से एस स्क्वायर कॉमन लिया और उसे इस टर्म से एक कंपेयर किया. ओके, सो क्या होगा, एस स्क्वायर कॉमन हो जाएगा, कैंसिल हो जाएगा, और ये a प्लस बी इज इक्वल टू 0 रहेगा. ओके, नाउ यू कैन टेक द टर्म ऑफ यस के जो टर्म्स हैं. Okay, so all the terms you can combine and compare with this one. So yes will be cancelled and you will get that is equal to 0. Okay, so here you can write that is 0.5. This is what, 0.5, or you can write 1/2 also, no issue. Okay, so 0.5 a plus 0.5 b 0.5 b, a हो गया, b हो गया, and then plus c also there, c will be also there, 0.5 b because cs is there. Okay, so plus c. Okay, and yes I am taking outside, so a yes or a 0 yes will be cancelled and you will get the simply 0 over here. So this is what, this is your equation number 2. कुछ डाउट है इसमें? नाउ द रिमेनिंग टर्म्स क्या बोलते हैं, 2a and 0.5c, that is equals to 1. Okay, so third equation will be your 2a plus 0.5c, 0.5c, that is equals to 1. Now from these three equation, in a first equation you can write a plus b is equals to 0. That means what, a is equals to minus b. Correct hai? A is equals to minus b. From this equation you will get a is equals to minus b. Now here you can put the value of a. If you put the value of a over here, so a is what? Or instead of b you can put the minus a, और यहाँ पे भी आप minus b put कर सकते हो, no issue. Okay, so a is equals to minus b, so I am keeping this as it is, 0.5 a and 0.5 minus b. Instead of b, sorry, I am putting this as a minus a. Okay, so 0.5 a minus 0.5 a, so that will be cancelled out and c is equals to will be 0. Okay, so if you put this value in this equation you will get c is equals to 0. Okay, so एक variable मिल गया आपको, c is equals to 0. Now you can put that value c is equals to 0 in this equation, in your third equation. So here if you put the c is equals to 0, so you will get the value of a, and what will be the value of a? That is a 1 by 2. Correct है? 1 by 2. And as a is equals to minus b, so b will be what? Minus 1 by 2. So like this you can calculate all these three variables. C is a 0, b is a minus 1 by 2, and a is a 1 by 2, and you can put all the values in this equation. Okay, so your h of s will be, कुछ डाउट होगा तो बोलो यहाँ पे. If you have any doubt you can ask. So your h of s will be, a is what? 1 by 2, so this will be 1 by 2 s plus 0.5 and your b will be minus 1 by 2 is there, so and c is 0, so this is I am taking this as a minus 1 by 2. S will be as it is, 1 by 2 s. C is 0. Okay, so this will be simply s square plus 0.5 s plus 2. So this is your h of s. Is there any doubt in this?
No, sir. Clear.
Okay. Now see here, to solve this, because still it is not in this term, you can easily solve, no issue. This is a 1 upon s plus pk. Okay, so you can write that 1 by 2 upon 1 minus e raised to power pk ts z inverse. Okay, but what about this term? Okay, so for that again you have remembered some formulas. Okay, that proof is also given in some books, or you will get the proof anywhere. Okay, so you can remember these formulas. First one, that is, if this is a known to you, s minus pk, like this, if it is there, so in a z transform, basically z transform is required. You studied in signal and system, so but z transform is required entirely for this subject also. Okay, so 1 minus for this z transform हुआ है ना, मैथमेटिक्स में हुआ होगा या सिग्नल एंड सिस्टम में हुआ होगा?
Yes, sir. SS में किया.
SS में नहीं था. Okay, so pk ts and z inverse. So this already we use, and this is known to you, z inverse. Okay, so now second term, the second formula will be, if you are having term like this s plus a, and if you are not having, so you need to check whether you can arrange the term in this manner or not. Okay, so s plus a, then s plus a square, means bracket square, s plus s a, this is a plus a, es plus a bracket square plus b square Okay, this is quite lengthy to remember. So this will be 1 upon, proof is also there, or you can prove this, no issue. So what you can do, you can consider this as a h of s. Okay, and to make this or to separate this bracket, what you can do, you can write this as a1 upon s plus minus jb in one bracket. Okay, and jba. Okay, and in another bracket you can write plus jba. Getting or not what I am trying to say? Okay, you can write this as a s plus this term, basically this term you can write this term as a s plus uh, a plus jb, like this. If you want to prove this, if you want to take the proof of this, so how you can start, you can write, take this as a h of s. Okay, and for h of s, for the separation, for the partial fraction, you can write this as a a1, this term a1 upon, you can take this as a s plus a in one bracket, s plus a in one bracket plus jb. Okay, and in another bracket you can take this as a minus jb. Okay, so bracket square will give you this term s plus a square and plus jb. Okay, so you can separate this term like this. Okay, this as a a2 you can take, and you can try to solve, so you will get the proof of this. Okay, so a2, so s plus a minus jb, like this, minus jb. Okay, so minus plus and jb square, so j square is minus 1, so this will be plus. Getting or not? ओके, माइनस जे बी, सो ये क्या होगा, एस प्लस ए ब्रैकेट का स्क्वायर माइनस जे बी स्क्वायर, ये फॉर्मूला होता है ना, ए प्लस बी माइनस बी, तो क्या होता है ए स्क्वायर माइनस बी स्क्वायर. ओके, सो दिस विल बी प्लस ए, ये एक ब्रैकेट होगा, माइनस जे बी स्क्वायर, बट जे स्क्वायर माइनस क्या होता है, जे स्क्वायर का क्या होता है -1, सो दैट माइनस विल बी प्लस एंड यू विल गेट दिस टर्म. Okay, so like this you can separate this and you can find out, now you can find out the value of a1 and square ho jayega a2 from this. Okay, so what you can do, for one h of s you can write as it is, and then there's this you can take jb as a pole, you can consider, and you can try to solve, same thing is there. Okay, so you will able to solve this. You can find out the values of a and b over here. Okay, a1 and a2. Okay, and you can find out this equation. Okay, so I'm directly writing this answer over here, because that term is required in our numerical, whatever numerical we have taken in that, it is required. Okay, so e raised to power minus ats, a will be what in this question, ये जो a रहेगा, so that will be your a. Okay, so ats, ts, if it is a given, uh, that value you need to take. If it is not given, simply ts you can write, or you can take 1 second. Okay, into cos, you can write this formula, into cos bts bts into z inverse. This is in numerator, and in denominator, it will be 1 minus 2 e raised to power minus a ts, minus a is here, ts into z inverse, sorry, minus 2 EATS, then cos in bracket, in square bracket, cos TS, cos BTS, BTS, Z inverse, Z inverse plus e raised to power minus 2ATS. uh, 2 3 time if you write this formula, you will easily able to remember this one. Or once you solve this, as I tell you this like this, if you solve this, so you will easily get this value, TS dot Z raised to power minus 2. Okay, so this is if you are having term like this, s plus a upon s plus a square plus b square. So this will be the Z transform of that terminology. Okay, so like this you will get. Okay, but here instead of this s plus a, if you in numerator, if you are having term s plus b, sorry, only b. Okay, so if you are having only b term and this is a s plus a, s plus a square plus b square. Okay, only change is that in numerator instead of s plus a you are having b. Okay, so in that case, all the things will be almost same. Just here instead of cos bts it will be sin bts. Okay, in numerator instead of this cos you need to take sin. All other things will be same. Okay, in from this formula I'm not going to write this again. You need to replace that cos in numerator with the sine. Okay, and this formula will be same as it is. This both the formula, second and third formula, you need to use in this numerical to arrange that terms. Okay, first of all you need to arrange that terms in this one s plus a, this and in this also. Okay, and then you need to find out the Z transform. First term, first all three formulas we are going to be used. First formula for the first term, but for second term you need to write that second term in this manner and this manner also, and both the formula you need to use to find out the Z ट्रांसफॉर्म. सो इसका Z ट्रांसफॉर्म जो है ये क्वाइट लेंदी होगा. ओके, so you can do that modification and you can try to write that. Okay, so what was the h of s we got for the question, for the numerical which we we were trying to solve? That is h of s is equals to something 0.5 upon s plus 0.5 है ना. So this term you can easily apply, no issue. This is what 1 upon s minus pk. Okay, s plus 0.5. So here value of that pk will be minus 0.5. S is equals to minus 0.5. So here you can apply that term. So to find out the Z transform, इस term के लिए कोई दिक्कत नहीं है. Okay, then the next one, that is 0.5 years, that is 0.5 years 0.5 years upon s square plus 0.5 s plus 2, 0.5 s plus 2. Okay, so this term you need to write some modification you need to
But there
do
will be
in this.
negative sign in between.
Sorry, कहाँ पे नेगेटिव साइन है?
और बीच में instead of plus.
here ना.
No sir, और first term के बाद.
या यहाँ पे है ना.
Yes sir.
Okay, so here negative sign is there. Okay, so this term you can easily write. This will be what? 0.5 upon 1 minus e to the power this minus 0.5, and ts is given in the question. ts is what? Not given. नहीं दिया है ना, ts नहीं दिया है. Okay, so ts you can keep as it is, or you can take one also, no issue. If you want to take one, then it will reduce your calculation part. Okay, because the terms are the lengthy over here, so take it as a one. Okay, so this first term will be simply 0.5 upon 1 minus e raised to power minus 0.5. Okay, z inverse. Okay, so that will be your first term. Okay, then for the second term, now you need to do some modification for this term. Okay, so you can write this as a 0.5. Yes, this is what 0.5 is. Okay, so what you can do, you can write this term as a minus 5. Okay, I am not writing this term, directly taking this one. Okay, so I will multiply this with the 0.5, this one. Okay, because value should not change. Okay, your original value should not change. इस तरह से modification करना है हमें. Okay, so 0.5 into, I will write this term as a s plus 0.25, 0.25, then plus 0.25, so it will be 0.5, s plus 0.25. Oh yeah, 1 plus, and here I will write this as a minus. Okay, so this will be simply minus 0.25. ओके, अभी ये क्या होगा, 0.25, 0.25 प्लस माइनस, सो ये कैंसिल हो सकता है. और यह जो है 0.5 मैंने आउटसाइड लिया और यहाँ पे 0.5 था. ओके, सो 0.5 0.5 कैंसिल होके सिर्फ यस यहाँ पे बचेगा. ओके, या फिर 0.5 को मैंने मल्टीप्लिकेशन में यहाँ ले लिया, ये 0.25 कैंसिल हो गया, ये मल्टीप्लिकेशन 0.5 यस. सेम है, वैल्यू चेंज हुआ नहीं हुआ है ना. 0.5 यस है, मैंने 0.5 को लिखा और इसमें क्या किया, 0.25 माइनस 0.25, सो ये 0 हो गया. ओके, सो यस है सिंपली, ये 0.5 यस हो गया. ओके, सो एंड देन दिस टर्म यू कैन राइट यस प्लस this we are going to be split, that is 0.25 square, means bracket square, 0.25 bracket square. Okay, then plus 1.39 square. Okay, now if you do this calculation also, this will be same, you will get this term s square plus 0.5 s plus 2. Okay, so this is a s square and 2 0.25. Okay, so this will be 2 into, so 0.5 s, this will give you, and 0.625 0.0625 if you square it. Okay, and then if you square it and add, so you will get 2. Okay, now again you need to write this, you need to rearrange this term into brackets. Okay, so while arranging this, so this will be simply 0.5. Okay, so 0.5 in one bracket, you can write this as a s plus 0.25. This is a s plus a, this is what, s plus a. Okay, and upon this will be s plus 0.25 bracket square. bracket square, so this is what, s plus a square. Okay, and plus b square actually, so plus b you can take this, that as a 1. Okay, b is a 1. what was your formula? S plus a square bracket. Okay, so plus b square, so b you can take 1. ओके, सो देन प्लस, सो ये फर्स्ट टर्म हो गया जहाँ पे आप ये फॉर्मूला अप्लाई कर सकते हो, यस प्लस ए स्क्वायर प्लस बी स्क्वायर. ओके, दिस फॉर्मूला यू कैन अप्लाई ओवर हियर. ओके, now one from this remaining part. Okay, so from remaining part what you can do, remaining is 0.5. Okay, and minus 0.5, so 0.5 this is multiplied to this entire bracket actually. Okay, so I have taken this part only. Okay, so here you can write this as a, this portion, that is 0.5 into minus 0.25, so that multiplication. Okay, and you can divide this by 1.39 to make it b अपॉन, अभी मुझे क्या करना है, ये b हो गया आपका यहाँ पे फिलहाल ये b है. ओके, सो मुझे इसे बनाना है b अपॉन in this format. Okay, so what I will do, this as a 0.5 multiply by 0. This one 0.25. Okay, so 0.5 into 0.25, 0.25, so that I can write this term in the form of b, 0.25, and 1.39 I will take outside, 1.39. Okay, you can make this as a one bracket. Okay, 0.5, 0.5, oh sorry, 0.5 I have taken for both the bracket, please ignore this. Okay, so this is 0.5, 0.25, 1.39. Okay, and in bracket you need to write 1.39, means it is a b, now it is a b, 1.39. Okay, so upon, yeah, so that thing, that is a s plus a plus b square will be as it is, that is 0. S plus 0.25, this is your s plus a bracket square plus b will be 1.39, 1.39 square. Okay, so this will be your b, 1.39 square. So both the formula you need to use. This is a s plus a upon s plus a square plus b, and here also this is a b upon s plus a plus b square. Okay, so 1.39, that's why we have taken outside, so that will be cancelled. Okay, and 0.5 and 0.25. Okay, so so just this is for the calculation terms. Okay, so now you can apply the formula over here. Okay, is there any doubt in this? Try to do it, try to complete it by your own. Okay, and if you have any doubt you can ask me in the next lecture. Try to solve it. Yeah, so try to solve it, and if you have any doubt you can ask me in the next lecture. Okay, so is there any doubt from your end right now? If you have any doubt you can ask. Okay, so thank you all of you. I'm going to end the session. Thank you for your attendance.